Manufacturing an inverter ceiling fan involves several stages, combining mechanical and electrical engineering processes. Below is an outline of the process. 1. Product design and development. Conceptual design. Design the fan's appearance, size, blade structure, and motor system. Engineering design. Optimize blade design for aerodynamics and noise reduction. Design the motor, often a brushless DC motor, BLDC, for high efficiency and compatibility with inverter technology. Develop an electronic control system, driver circuit, for smooth speed control. Design the inverter module for low power consumption and efficient voltage conversion. Prototyping. Create a working prototype and test it for performance, energy efficiency, and durability. 2. Material procurement. Blades, material, aluminum, ABS plastic, or composite materials for lightweight and durability. Motor, copper wire for windings. Magnetic materials for rotors. Steel or iron for the motor core. Electronics, microcontroller units, MCUs for smart features. MOSFETs, diodes, capacitors, and resistors for the inverter circuit. Sensors like Hall effect sensors for speed control. Housing, die-cast aluminum or steel for the motor casing and ceiling mount. Top 3. Component manufacturing. Blade fabrication, injection molding for plastic blades or stamping and shaping for metal blades. Surface treatment, e.g. painting or powder coating for aesthetics and corrosion resistance. Motor manufacturing, wire winding for the stator. Assembly of the rotor with permanent magnets. Testing motor efficiency and heat dissipation. Electronics assembly, PCB manufacturing for the control circuit. Component placement using SMT through-hole soldering techniques. Programming of MCUs for inverter control. PAF4 assembly process. 1. Motor assembly. Mount the stator and rotor. Install bearings and ensure proper alignment. 2. Blade attachment. Secure blades to the motor hub with precise torque for balance. 3. Electronics integration. Install the driver circuit and connect it to the motor. Integrate sensors and controls. 4. Housing and finishing. Enclose the motor and electronics in the housing. Install decorative and safety covers. 5. Wiring. Add connections for AC input and control interfaces, e.g. remote or wall-mounted controls. Quality control and testing. Functional testing. Verify speed control across all settings. Test inverter functionality and energy efficiency. Durability testing. Run continuous operation tests to ensure long-term reliability. Check for noise levels, vibration, and heat generation. Safety testing. Test for electrical safety, short circuits, insulation resistance. Validate compliance with regulatory standards, e.g. CE/UL. 6. Packaging and distribution. Package the fans with all components, including remotes, installation guides, and accessories. Use eco-friendly materials for packaging when possible. Distribute products through warehouses to retailers or directly to customers. Number 7. Post-manufacturing support. Offer warranties, after-sales service, and spare parts. Continuously gather user feedback for future product improvements. By following this structured process, manufacturers can ensure high-quality, efficient, and durable inverter ceiling fans.